Hello, how's it going? In this video, I'm going to put a gun model in my scene, but I'm not going to do it in a straightforward way where I've just got another model that I render as part of the world out there in world space. I'm going to use a trick where I have one frame buffer, one layer, which is the whole world, another layer onto which I render the gun, and then I'm going to composite those together. This will have the benefit of later on, if I want to apply some effects, I can use the view of the world to do some screen space stuff. And it also has the effect of, although this is honestly going to take a long time, there's a lot of little refactorings that I'm going to do, it will make the renderer more general and more flexible. So I've got my little list of items that I want to cover. First of all, I'm going to be dealing with multiple frame buffers. So in order for that to work, I'm going to give each frame buffer its own depth resources, and I'm going to give each frame buffer an interface that I can use to quickly start rendering to it. So I'll say frame buffer has use and draw to and read from functions. Okay, then I guess the next item is I'm going to make a frame buffer to represent my gun object, and then I'm going to make a shader for my gun. All good. Then I'm going to make a bind group for my gun. Then I'm going to have also a bind group layout and a pipeline. But I guess before I make my pipeline, my gun model, my gun mesh, is going to use a different vertex buffer layout to my other meshes. So far for my other meshes, I've been using positions and texture coordinates, but not normals. I'm actually going to use normals in this gun model because I may need them later on. So I'll say object mesh has flexible layout. That's what I'll call it. So when I make the object mesh, at that point I can specify which attributes I want to use from the OBJ file, and it will dynamically construct its layout, which will be used by the pipeline. So with all of that, I'm going to start constructing. We'll have a material for a gun, we'll have a mesh for a gun, and then just looking through my list, then the gun is, the object mesh is going to need to take some sort of pre-transform. And this is so that when I make the gun, I'm not going to be rendering that mesh in world space, I'm going to be rendering that mesh in screen space. And so it will be really helpful if all the vertices of the mesh have already been transformed to put them into the appropriate position already to put that thing in the screen. And there's one more thing, and that is really tying it all together. So I'll say gun render pass. This will render the gun out to that external frame buffer, and then composite the views to get that all together in the single view on the screen. So as you can see, there's actually a lot of steps involved, but we'll just take this one bit at a time. So for one thing, the frame buffer is going to need some sort of depth resources. So I'll go into my renderer, and in this renderer, I've got these sections down here, this depth stencil stuff. I'm going to grab all of that and copy it. And I'm going to go over to my frame buffer class, and just down below, I'll put in these extra members. But there's one thing I'm going to do. So it's possible that we make a frame buffer which actually does not need any depth resources. And so I'm going to say that this can possibly be undefined. And just for debug purposes, I'm going to give this thing a label, call that name, and I'll give it a constructor where I'll just save in that name. Okay, excellent. So in addition to all of this stuff, I'm going to take in an extra flag, which will indicate whether I want to use depth resources in this frame buffer. And then based on that, we will go over, and I've got this function. Okay, so right down here where I initialize things, I'm not going to do that. And then I'm going to grab that, that make depth resources. And rather than doing that in the renderer, I will do that in the frame buffer class. So right down the bottom, we'll make a new function, ready. And I'll just need to refactor things a little bit. So I'll take in a device and I'll use that to create these things. And I'm also going to take in a canvas. Okay, that should be fine. So what I'll do is in my initializer, I'll say, if we are requesting depth resources, then go ahead and make those. I'm happy with that for now, so I'll mark that off my to-do list. The next thing I'm going to do is, let me just okay, so we'll have some issues here. Right, so just a little bit of refactoring. So that was the pipeline, yep. So I'll just access the depth resources from the appropriate frame buffer. And there might be a little bit more down here. Okay, new frame buffer. We're going to need a name. I'll say, okay, so we will need, true. We do want to use depth resources in this case. Right, so down here, this is complaining at me saying, hey, what do you mean? We need to do rendering. And what I'll just go ahead and fix this up for now because that fixes the error, but we can take it one step further. And that is, we've got this frame buffer. We know that we want to draw to it. So I'm going to go to that frame buffer class, define a draw to and read from function, and that will make this a lot more straightforward. So the way my draw to function works is I'll say, hey, this frame buffer, this is the thing we want to draw to, and it will give me back a render pass, which I can use. So I'll actually grab this stuff here and I'll go over to my frame buffer and I'll say, make a function, which is basically going to return all of this. So in order for this to work, we're going to need to take in some sort of command encoder object. So then shorten that quite a bit and that will work. But we can actually make this even more straightforward because as you can see, there's color attachments. There's nothing special about this. This is all using information which is known at any point in time after initialization. So what I'm going to do is I'm going to define another member up here, call it color attachments, and that will be a list of, I think it's color target state. No, it's not, sorry. It's, render pass color attachment. So some list of those, and in the initializer, we can go ahead and set that up. And I'm just going to make a little adjustment here. So for the clear value, I've determined that a clear value of 0, black, is the safest. Specifically this alpha value, because I want to have some way, when I draw my gun, not every pixel on the screen is going to get drawn to, and I want to have some way to detect which pixels I should discard because I don't want to overwrite the view of the world. Because this is going to go on top of the world view, and even if I'm just drawing the world, every pixel is going to get drawn anyway. So for me right now, this is a good safe clear value, clear color. So here for this color attachments, I'm going to put in that list just like that. It's gotten quite a bit simpler, and just for fun, I'm also going to have this read from function. So if I go down to the draw screen, we can see where this is happening. It's the bind group stuff here. So I'm going to take that, even though it's a one-liner, it just makes the interface a little cleaner. So then similarly, we're going to need a render pass to work with. And I'm also going to take in a binding index, because right now the binding index that I'm binding to is 0, but there's no guarantee that that will always be the case. Cool, okay, so I can go back to my main code and put those changes in place. So right here, I can say get that frame buffer and read from it, just like that. And the rest of this is fine because I do need to be getting a handle to the appropriate texture. That's handled by the swap chain. That's nothing that I have any control over at this point. But up here, I'm going to go with this. So we'll have... cool. So just scanning through, I think that's fine. And it's gotten a lot cleaner. Like, this is looking nicer. Okay, so looking at all of this, we can say, righty, we've now got a much more general frame buffer. That's really good. So now I'm going to make a gun frame buffer. It's not too hard to do. I'll just go up the top with my resources and say gun frame buffer, like that. And then down below where I make the resources, I'll just do the same as I've got here. It's probably a good idea just to run it periodically to check that I haven't accidentally broken anything. Okay, yeah, that looks fine. Okay, so I'm happy with that. We've got the gun frame buffer. Now for the gun shader. Now this gun shader is going to be just a much simpler version of the existing world shader. So I'll go into my shaders and I'll make a new file, call that gun shader. And I'll go ahead, grab my standard shader, put that in, and I'll say, okay, what needs to change? Well, for one thing, we're not going to have, now that's fine, we're still going to use that, but we're not going to have the model data. So we're just not going to have that at all. And we still are going to have a sampler and a material. As for the fragment that we're outputting, I'm not using normals at the moment, but I'm going to declare them anyway. In the next video, I'm going to use normals, but it just seemed like a little bit too much for one video. So I'm not going to take in the instance index. And we'll take in all of that data. Great. And now, as we can see here, we're not going to have a model transform, and we're not even going to have a view transform, actually. I pretty much just want to get the model and project it on the screen. I'm assuming that everything has been set up properly. All of that should be fine. And then looking down here at this texture sample, this is all. Okay, so with that all set up, we can close that down and say, alrighty, we've got the gun shader. That's all good. Now, the gun bind group layout. Well, we really are starting to repeat ourselves now. That's perfectly fine. Well, remember, the thing is with the bind group layouts, we can actually get this on a per pipeline basis. So I'm just going to go into model definitions, and I'm going to define a new type of pipeline, and then I'll do the usual, right? So I'll go back to my renderer and where I construct, is that the one? Yep. I'll go ahead and put in some pipeline entries. Okay, cool. Then I'll go to the function where I make my bind group layouts, and I'll pop in here, and I'm just going to have that uniform buffer. So I'll say add buffer. The buffer will be used in the vertex, and it's just that uniform buffer. So with that, we can go ahead, and there we have it. We've got our bind group layout. Cool. Okay, now for the bind group. Now the funny thing about this is that I do need to make a distinct bind group. Okay, so I'll go up and I'll say, okay, we're going to have we've got a frame bind group. Okay, excellent. So again, we're all set up, good to go. So write down, make bind groups. I'll just go ahead and actually copy what I got here already. Okay, so this is the gun layout that I'm taking in, and then I'm going to add the uniform buffer, and then that's it. And I'll save that into the gun. Right, so now this next bit's going to take a while. The OBJ mesh is now going to have a flexible layout. And what I mean by that is in the OBJ file, if I just open up one of these models, you can see that we've got all this like V, VT, VN. Right now, like I said right at the start of the video, I've been ignoring this VN, but I want to make things as flexible as possible. So I'm going to make my object loader such that when I load the object, I can specify which attributes I want to pay attention to, and then construct the vertex buffer layout based on that information so that I can go ahead, I can load in all of my models, and then when I construct the pipeline, at that point I can take one of the models and say, hey, this is a typical model which is going to be used on this pipeline, this is its layout, you need to expect this, and it'll handle it. So what I'll do is I'll just go to my obj mesh file, and at the point where I initialize things, I'm going to take in 3 extra variables. And I might as well just propagate them all the way through as well. So we take this in, and then we have, where are we? Here we are, in the read file function. So in this read file function, that read file is going to take that information as well, and then it is going to pass it along when we come to read the face data. So no matter what, it's going to read in, my bad, no matter what, these functions are going to be executed, they're going to read the data. But then when we come to reading the face data, that will also take into account which attributes we want to pay attention to. And then likewise, that will pass it along to the read corner function. So there is going to be a lot of copy pasting going on here. So let me just go. Okay, so then I'll just go along and spread that through. So far, so good. So that's the easy part. The trickier part is building the attribute. So let's say we've gone ahead, we've read all this stuff, and just before we work out how many vertices we expect to have, I'll declare some stuff. So I'll say, all right, we'll have a set of attributes, and that will be a list of GPU vertex attributes. I'm also going to need to keep track of how many floats there are per attribute and how many attributes there are per vertex. Although technically we don't need that attributes per vertex because we could just use the length of the attributes list, but this is just for readability. Now there are, I guess, slightly more elegant ways I could do this, but I'm just going to brute force it at the moment. It's really not that bad. What I'm going to be doing is doing some different actions depending on which attributes are enabled. And then when it comes to doing this stuff here, I'm going to take the number of floats, really, that I've loaded in, and then divide that by the number of floats per attribute, and that will let me work out how many vertices I actually have. Floats per attribute should really be floats per vertex, shouldn't it? And then likewise, if I go right down the bottom, when it comes to creating this stuff, the array stride, every float has 4 bytes, so it'll be 4 times floats per vertex, and the attributes, yeah, I'll get rid of that, will be our attributes variable. Cool. So it just comes down to building those attributes. So if I go up on this, in this case, I'm going to push on a vec3. Okay, should be pretty self-explanatory, and we can do the same thing in all these other cases, except of course with the texture coordinate it's a vec2. Okay, so the only other thing to do is, I guess, when we come to actually loading the data. So we'll just go right down the bottom where we actually load this stuff in. Okay, so in the case where we've got V enabled, we'll go ahead and push all the V stuff on, and same thing for texture coordinate, and the same thing for normal. Cool, because all that stuff is loaded in there anyway, it's just I've been ignoring it. So hopefully this should be set up, fingers crossed, and it's probably a good time to test it. So if I just go to the create asset stuff where we initialize this, we're going to need to specify a few things. So yes, I want positions, yes, I want texture coordinates, But no, I don't want normals. Let's just test and see if that is working. Okay, that's working just fine. So, object mesh has flexible layout. That is done. Gun pipeline. So gun pipeline is going to need a layout. So we're going to need to vertex buffer layout. So we're going to make a gun mesh first. So we'll have a gun mesh. Okay, I'll just go down and grab this and then right down here and create assets. Okay, so if we look in the folder, we've got this distribution folder, and in there we've got these models, and then we've got this gun.obj. So that's what I'm going to be loading in. So I'll go ahead, we'll construct a new gun mesh and we'll initialize it. And for this, we will be taking in normals. Again, not using them right now, but we will later on. Yeah, that's it. So gun material done. Okay, pipeline. So I'll just go down to where we make the pipelines, and we're going to need to import that gun shader. So we'll go ahead and import. Cool. And then source code is starting to get a little big. Okay, so we're making a gun. Yeah, we're using the material layout as well. Going to use the gun shader. Just repeating everything I see. Okay, so vertex buffer description will be the description of the gun mesh. Great. Depth stencil state will be the gun frame buffers depth stencil state. Awesome. And then the render target. Yep, that's fine. Cool. So hopefully you can see, even though there's a few steps, it's starting to get pretty good. This is starting to be a good experience. So I've now got a gun mesh and a gun pipeline. All right. Object mesh takes pre-transform. You know what? Let's leave that for now. I'll play with that in a second. But let's go ahead, make a render pass, and then composite all the views together. So I'm just going to go right down. Yeah, this is a nice simple function. Actually, I changed my mind. Okay, so we don't need to prepare the scene because that has already happened, and the uniform buffer object has already been uploaded to, basically. All we need to do is refer to it. So we'll go ahead and begin the gun frame buffer. Then I'm going to get my gun pipeline. I'll put in object 0. Yep, object 0, and then my bind group. And then I'm also going to need to set my vertex buffer. So I'll say, alrighty, render pass, set vertex buffer. This will be buffer slot 0. And then, yep, the vertex buffer, that's fine. Then finally we'll draw, and we'll just need to put in the vertex count. So we'll go this gun mesh. I said, there we have it. We can get rid of everything else. So really, truly, that's how simple it is. We've got a small number of resources. We've got an external frame buffer we're drawing to. Just set it up and go. Okay. Now, as far as compositing those views together, again, it's surprisingly simple. What I can, I should probably also go draw the gun. Right, so now drawing the gun. So again, surprisingly simple. Oh yeah, I'm going to use the post-processing pipeline. I'm going to read from the gun frame buffer and just draw a quad. So we're just blitting that gun texture onto the screen. So I'll go ahead and run this and see what it's looking like. Okay. Oh man. Here we go. Okay, that was an easy spot actually. So what happened is I made the gun frame buffer, but then I initialized the frame buffer. Okay, so let's have a look at this again. Okay, so currently we are seeing nothing. We can walk around, we can move around, we're seeing nothing. And that's actually what I expect, because remember, we've got the gun, but we've got alpha blending. So because of alpha blending, well, actually we haven't got alpha blending, which is probably why it's messing up. But long story short, we need to be discarding all the fragments which have an alpha of 0. So this is actually overwriting the view of the world. So what we can do is just go to the post-processing shader, and in that post-processing shader, right after we sample the color that we're looking at, we then have our discard test. So we'll say if the color alpha is less than 0.5, I guess, really doesn't matter, just needs to be some number, then, so this will make sure that we're seeing the world underneath the gun. So as you can see, we've got the world as normal, the gun's hanging around here, but we haven't really... We need to apply a pre-transform to get it into the correct orientation. So we'll close this down, and now this is the last bit, is the object mesh needs to take a pre-transform. So I will go over to my object mesh, and now, as well as all of this, I'm going to need the vec4 type and a matrix 4. So when we initialize, as well as all this info, we're going to take a pre-transform, which will be some 4x4 matrix, and we're going to pass that along to the constructor, the object reader, and then same thing. So on the read file function, we're going to take in that pre-transform, and we're going to pass that along when we read positions or normals. They're going to need that transform. Okay, so this is a little janky, but we'll see how it goes. I'm actually going to construct a vec4 rather than a vec3, and so we'll start with the new vertex, and then v will be some variable which is the transformed vertex. So we can do this by saying vec4 transform mat4. We're going to output the result into v. We're going to take the new vertex as our input, and we're going to take the pre-transform as our output. Then when it comes time for this, we're going to put in the x, y, z components of that transformed vector. So side note, the reason that this is taking in a vector v as well as outputting, it's a little strange, but it comes down to not wanting to do extra memory allocations. So the library forces us to allocate anyway and then put that in. I don't 100% understand it. It's a little weird. Okay, so in the case of a normal, it's the same, but remember that it's this 1 on the end, which allows us to do translation. But if we keep this as a 0, then no translation occurs, and it's pretty much just, well, scaling and rotation, which, good point, we should probably normalize this thing. So take new normal, that'll be a vec4. Talking to myself a lot today. What I'm going to do is try to normalize this. Cool, okay. So, oh yeah, we want to put that into the normals. So, fingers crossed, that should be fine. All I'm going to need to do is apply this same stuff up here. So up here, I'm going to have some pre-transform variable. Oh, I'm going to need this, right? So just go up, and I've got mat4. I'm just going to take, I think I'm going to need vec3 as well for some of this other stuff at create. As it says, this creates a new identity matrix, so we can go ahead and put that in, and that will have no effect. But then down below, I'm going to do a few things. I'm going to do them in order to try to show the effect. So one thing I'm going to do is I'm going to scale the gun because it's a little too big at the moment. Okay, so I've just created this transformation. I've stuck a scale transformation into it and then stacked that onto the pre-transform. We can just go like that. And let's give that a go, see what it looks like. That's not the effect I was intending. So it seems as if I've created the correct thing, but by accident. Look, I'll be honest, I don't completely understand how this transform chain is working. I just sort of tweaked it and played around with it until it started working. So for some reason, if I put a scale on just by itself, nothing happens. But then if I include that, it does work. I don't know. Completely do not know. But it's also getting the wrong texture. So I think I need to re-examine that because I don't have a gun material. Okay, well, like I said, I don't completely understand, but in the end, the measure is whether it works. So I'll just have another look at that transformation, and I am reasonably happy with that. We can probably bring it over a little bit, and then we can go to the draw gun stuff, and we can bind the gun material. And I'm also going to go to that post shader, and instead of returning all of that stuff, I'm just going to return the color with no change, just to really check that it's working. Cool. Oh yeah, and look at that. So we can see here that the gun is facing towards us. So we're going to need to rotate it around. So let me just get onto that. So this is pretty good. I'm just going to need a few things. I'm going to need the converter. Oh, does that not work? Well, let's find out. So there we go. So I'm just going to spin it 180 degrees around the y-axis, and fingers crossed, hey? And now I might need to change. Yeah, okay. Okay, all good. All good, we're almost there. So I've just adjusted the translation a little bit. Like I said, it's not super exciting. It's just a lot of like tweak this, tweak that. Just put that however you'd like. We could probably bring it a little closer to the center, but it's really just a matter of taste at this point. So as you can see, we've got the gun. It's pretty static at the moment, but we could animate this with some attributes. Like we could put in a T parameter, which is just incremented as we walk around. We can get that moving around. This is rendering, again, the gun and the world as a different layer. So in future videos, what I'm going to do is I'm going to look at sampling info from the world and using that in the gun. But we also have the advantage that we can get really fell through the floor. We can get really close to objects, and you know, it looks a little strange, but the gun sort of, I don't want to make this a weird video. I won't look there. But the gun sort of, we can get close to the wall basically, and the gun doesn't push through. So there we have it. It's looking pretty cool, sort of like Counter-Strike or something. And I will stop talking. So I hope you enjoyed this, and I will see you again soon. Happy coding. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.